kids, remember those days when your teacher got sick and you didn't have to do any work? Those days are long gone, kids, long gone. I don't find my mouse pointer. Anyway, what I'd like you to do today is just get through this warm-up, and then I'm going to give you some notes, and then I'll give you a short homework assignment. Hopefully I'll get there pretty quickly. Once you understand what's going on, you can either go through the video quickly, try to use headphones, though. Nobody wants to listen to my voice, especially today. So, without further ado, without wasting your time, I'll try not to make too many coffee commercials, but that's the only thing keeping me even conscious right now, so I don't even know how to get rid of this stuff. Get off my screen. Oh, there we go. Alright. Oh my gosh. Just leave me alone. Alright. I may be whining like a little baby, only because, quite frankly, I'm not a very good sick person. I hate being sick. Alright. So, these are your warm-ups. So, pause the video, spend a couple minutes taking a look at them, see if you can do these first two. You should probably pause it and not watch a trained monkey perform. This is all review from last year. You should be able to do this. All right. So I guess you're back. Hopefully you're back. Hopefully you took me up on it. So a couple different ways you can do this. I know Mr. Hertwig likes to do it this way. I don't really care. We're going to separate this into perfect squares and not perfect squares. Yes, I cannot write on this tablet thing very well. So anyway, what you want to do is you want to find the largest perfect square that goes into 200. You did this in 9th grade. You did this in 11th grade. You should have done this a million times. There should be no issue. The largest perfect square is 100. So 100 times 2. I mean, obviously 25 goes in, but it's not the biggest. And then this is x cubed. So that's basically 3 x's, right? But we're working with a square root. So I can only use 2 as a perfect square. So we'll put that there, and then the leftover 1 goes here. And then this turns out to be, because this thing right here is really just 10x. 10x square roots of 2x. All right, so now we're working with cubes. So now when we're working with these variables, if you remember correctly, what we're looking for is groups of 3. So any groups of 3, we're in pretty good shape. So I'm going to rewrite it as perfect cubes, not perfect cubes. All right, so a to the 4th has an a to the cube in it. So I'm going to do a to the cube, but there's still 1 left over here. B to the 8th. Remember, if you're going groups of 3, right? The biggest one is b to the 6th. And then b squared. And then finally c to the 12th, that's already groups of 3. So you'll look at these numbers right here. These are all multiples of 3. They're the largest multiples of 3 that went into these things. And then we have our leftover stuff. All right, so the cube root of a cubed is a. The cube root of b to the 6th, since that's 2 groups of 3, is b squared. And the cube root of c to the 12th is c to the 4th. Cube roots of a, b squared. Now I'm going to try not to forget these things here, but you got to remember those too. All right, on your quiz on Wednesday or Thursday, we're going to do a whole day of review, so don't worry about it. You're going to have some true falses, right? So pause this real quick and see if you can figure out if these are true or false, and then we'll start with our notes. Shouldn't take too long, I don't think. Things you remember to do. So is this true? The answer to this first one is yes, this is true. Now you may not know it right away, but I know when I taught my kids this. I'm going to show you something a little bit different this year, but I taught my kids this. I remember this as being b over 1, right? So when you take one fraction and you divide by another fraction, that's the same as multiplying by the reciprocal, 1 over b. And if I do that, multiplying by 1 over b now. So this gives me x over ab, which gives me this. So it's true. There's another way to do it, but I will show you that in a couple of days. If you said this one is true, man, oh man, I'm going to knock you out, okay? When you've got adding or subtracting, kids, you got to do things totally different, right? You need a common denominator. What's the common denominator between x and b? The common denominator between x and b is xb. So I need a b here, and I need a b here. I need an x here, and I need an x here. So this is equal to AB plus AX all over XB, which is not that at all. So this would be false, right? False. All right, let's get to some notes. All right, day 4 notes. So today's day 4. Tomorrow we will review for the whole period. If I'm not there, I'll have a review assignment with a review video. And then Wednesday or Thursday, I'm definitely going to be back, I'm sure. And we'll have a quiz, and I'll do a little review before the quiz just to kind of give you like a little help stuff. So this is, I don't even know, what is today? 9/16/24. I can't write on this thing very well. And this is day 4. And we are rationalizing. So we're going to do some rationalizing. All right, so the directions for this are rationalize the denominator. So our first problem is 1 over the square root of 2. So you guys probably should know this, God, I hope you do, that this is not a rational number, right? That is an irrational number. If you put the square root of 2 in your calculator, you get 1.414 and then a fistful of digits, whatever. So I want to rationalize it, right? I don't want this irrational number in the denominator. I want a rational number in the denominator. And there's reasons for why you're going to do this. We'll talk about that as we get into some harder level math this year. But well, you just got to understand this skill. So what we're going to do, if you remember correctly, is we're going to multiply by 1. Because multiplying by 1 does not change the value of anything. But the way I'm going to multiply by 1 is weird. I'm going to create a 1 that's weird. And that is because I want to multiply by the square root of 2, or I want to get rid of the square root of 2, I'm going to multiply by the square root of 2 over the square root of 2. Now that's just a real fancy 1. Still just 1. All right, so we multiply the numerators. 1 times the square root of 2 is the square root of 2. And the square root of 2 times the square root of 2, I hope you all realize is the square root of 4, but that's just 2. And there's your answer. All right, oh my God, go away. All right, let's get a little coffee in before we go to the next one. The next one's a little weird. So that's review from last year. Let me give you one more like that one. Then I'll give you the weird one. So 2. How about this? 7 square roots of 5 over 3 square roots of 3. So I want to rationalize the denominator, right? So this thing right here is the problem. I don't want that radical 3 there. I don't care about this 3. It makes no difference to me. And because they're multiplying, I don't really care about it at all. We'll talk about the adding, subtracting stuff later. So I'm going to multiply by 1. It's a very fancy 1. I'm going to multiply by the square root of 3 times the square root of 3. So in the numerator, I get 7. Now, if you remember correctly, you can multiply radicals together. So this is radical 5 times radical 3, which is radical 15. Now this 3 kind of comes along for the ride. We're not doing anything, it just stays here. These two radical 3's, when you multiply radical 3 times radical 3, you get 3. So this 3 came along for the ride, just right here. And then these two 3's, made up this 3. And so my final answer on this one is 7 square roots of 15 over 9. All right, let's get to a weirder one. Number 3. All right, this one, this is not review. This is new, sort of. 4 over the cube root of 7. So when we want to do it for a square root, right? This is a square root. Let me see if I got this a little bit neater up here. This is a square root here, right? Square root, right? So I multiply by a square root, right? Because this already had a 2 in it. I multiplied by another 2. So basically I'm squaring the thing, and then a square root squared cancel each other out. So that's kind of how you want to deal with these. And I was always wondering how I was going to teach this, and I saw Mr. Hertwig, I talked about it, and I'm like, oh, that's a neat way to do that. So that makes it easy. So think about it. This is going to be a very easy way to do this problem, right? Right now, underneath this radical, there is 1/7. Now, in order to make that a perfect cube, in order to make that a perfect cube, if I multiply just by 7 over 7, how many 7s would I have underneath there? I would have 1 7 and another 7. So I only have 7 squared. Squares and cube roots don't cancel each other out. So I need 3 7s, because that would make it 7 cubed, and that would cancel with a cube root. So what you want to say to yourself is, okay, I have 1, I need 2 more. Bear with me on this one. So in the numerator we get 4 cube roots of 7 squared. I'm going to change that in a second. All over the cube root of 7 cubed. All right, so the numerator is 4 cube roots of 49, because 7 squared is 49. All over, and then you'll notice here I got a cube and a cube root. They cancel each other out, all over 7. It's not that bad if you think about it that way. This one's a little bit more challenging. Let me step the game up a little bit. 4. I don't know what happened. Sound like smooth Carl Hansen. Ah, man. All right, let's do this again. So I'm going to start with 1 over the 4th root of 27a. So before I try to tackle this problem, some of you can see it and some of you can't. That's okay. I'm okay with that. I want to take an in-between step, kind of rewrite this a little bit differently. I'm going to rewrite that 27. All right. Do you guys recognize that 27 as a perfect cube? So that's 3 cubed and a. So the 27 became 3 cubed, and then the a just stays the a. So as I look at this, I say to myself, okay, I need 4 of everything underneath there. I need 4. Right now I have 3 3s and only 1 a. So what do I need? I need another 3. So remember, this is going to be a 4th root. I need another 3. And I need 3 a's. In other words, I need a cubed, right? Because this a and this a cubed would give me the 4 a's I need. That 3 cubed and the 3 would give me the 4 3's I need. But remember, this thing that we're multiplying always has to be a big fancy 1. So whatever you put on the denominator, you're going to put on the numerator. And that's supposed to be a 4. All right, so in the numerator, I get the 4th root of 3a cubed. In the denominator, I get the 4th root of 3 to the 4th, a to the 4th. Now, you can skip this step if you already know that it's just going to be 3a, right? So in the numerator, my goodness, and the numerator just stays. It is the 4th root of, that's a 4, 3a cubed, all over. Now, the 4th root of 3 to the 4th is 3. The 4th root of a to the 4th is a. And you now have rational numbers in the denominator. All right, we're going to do one more. You want to try this? Maybe you want to try this one on your own a little bit to make this one up. So let's go with 6 all over the cube root of 5x y squared. Now, if you want to do this one with me, that's fine. If you want to do it on your own, just pause the video and then you can just fast forward to see how you did. So, I encourage you to try to fast forward and do it on your own. But if you can't, you want to watch me do it, I don't mind being the train monkey. All right, so we're gonna multiply by a cube root over a cube root. I don't know why that pops up all the time. So if you'll notice here, I have 1 5. But how many 5s do I need? I need 3. So I need 2 more. I have 1x. So I need 2 more x's. I have 2 y's. So I need 1 more y. And so whatever you put down here, because we have to multiply by 1, that goes up here. All right, so in the numerator I get 6. Oops, this should be 5 squared. 6 cube roots of, and I'm just going to write it out, 25x squared y all over. Now, these two are going to give me the cube root of 5 cubed, x cubed, y cubed. That's what they give me. And then the cube root of 5 is 5. The cube root of x cubed is x. And the cube root of y cubed is 1. And that's all there is to dealing with the cubes. All right, not a big deal. All right, those aren't too bad. Let's talk about when there's a binomial. These are a little bit trickier. I have no idea what number I'm on. We'll go with 6. Number 6. What if I gave you this? 4 over 2 plus the square root of 3. Now, if you had me last year, I taught you something on these to try, and I beat you over the head with it, trying to drive it home. Because kids that don't think or don't do what I ask are going to sit here and go, okay, let's multiply by radical 3 over radical 3. Please don't do this. Now, in the numerator, I would get 4 radical 3. But the denominator, I got to distribute, so that'd be 2 radical 3. And then radical 3 times radical 3 would be just 3. Well, that's a problem because this is still an irrational number in the denominator, and you can't have an irrational number in the denominator. So don't do this. Now, hopefully some of you guys remember that word that we use. It starts with the letter C. First thing, what did I teach you guys last year? I beat you over the head with it. I said, please, anytime there's adding and subtracting, put it in parentheses. And hopefully you remember this word. Let me know when we get back to class if you remember this word. But what we're going to multiply by is the exact same thing as the denominator, except it's going to have the different sign, minus. And this is called the conjugate. It's called the conjugate. Multiplying by the conjugate. Now, please do me a favor. Don't multiply in the numerator. Just leave it. 4 times 2 minus the square root of 3. What I mean by that, I should have said don't multiply. Don't distribute in the numerator. Now, here we're going to multiply these. We can multiply these two together. I get 4. Now, these would give me minus 2 square roots of 3. These would give me plus 2 square roots of 3. Just like last year, they go away. And so what is the square root of 3 times negative square root of 3? Minus 3. So now my denominator is really just 1. So my answer is 4, parenthesis, 2 minus the square root of 3. And you do not need to distribute. Just leave it like that. It's a perfect answer. Now let's do another one. Let's do 20 all over the square root of 9. Nope, not square root of 9. That's kind of boring. The square root of 11 minus the square root of 5. Let's do that. All right. So we've got 2 square roots in the denominator now, so it's a little more complicated. No big deal. But we're going to multiply by the conjugate of this. The exact same thing, but with a plus sign. So square root of 11 plus the square root of 5. The square root of 11 plus the square root of 5. So in the numerator, I get 20. Don't distribute. Just leave it. Square root of 11 plus the square root of 5. All right, so these two make 11. Square root of 11 times the square root of 11 is the square root of 121, which is just 11. This is minus, that's plus the square root of 55, and this is minus the square root of 55. It's like last year, they go away. And then negative times positive is negative. Square root of 5 times square root of 5 is 5. But what is 11 minus 5? 11 minus 5 is really 6, correct? Now, this is why you don't distribute the numerator, because I want my answer in simplest form, right? Doesn't 2 go into 6 3 times, and 2 go into 10 times? So my final answer is 10, parenthesis, square root of 11, plus the square root of 5, all over 3. All right, this next one's new, a little bit new. I don't know if you noticed, I take a few breaks every once in a while, I have to pause it. My dogs are making noise. Noise upstairs. Just can't wait and wait. So this one's a little bit different. This time I want to rationalize the numerator. And as we go through some higher level math and get into some of the harder level math that we're going to be doing sometimes it's going to become important that you can rationalize either the numerator or the denominator to get to a place where it's a problem that you can manage. So you'll see that later on in the year, but don't worry about it for now. Just understand that you have to learn this skill. So I'll start with an easy one. The square root of x minus the square root of 3 all over 5. Okay, so I want to rationalize the numerator. You know, more than likely this is irrational. This is definitely irrational. So I want to get rid of those radicals. So what I'm going to do is put this in parentheses. And I want to multiply. Oh, you piece of crap. I wish you'd just leave me alone. Oh, wait, hold on. Oh, never mind. All right. And then I'm going to multiply by the conjugate. Which, again, is the exact same thing as before. It's just with a plus sign in the middle now. So square root of x. Square root of 3, geez. Square root of x. Square root of 3. All right, so in the denominator, we just get 5 times the square root of x plus the square root of 3. In the numerator, we get the square root of x. Oops. Oh, I made this easier, and I realized I needed to make it. Okay, never mind. We get, oh, shoot. Sorry. We're going to multiply the square root of x times the square root of x, and we just get x. And then this is positive square root of 3x. This is negative square root of 3x. And then negative square root of 3 times positive square root of 3 is negative 3. And we're done. All right, so let me try this one. This one's going to be a little more interesting, this problem. What if I give you the square root of y plus the square root of 7 all over y plus 7. So these aren't the same things, but so we're going to put them in parentheses and we're going to multiply by the conjugate of the numerator. So again, the numerator is a plus, we're going to multiply by the minus. So this is the square root of y, square root of 7, square root of y, square root of 7. So in the numerator, oh, I needed this to be a minus. Sorry, just change this to a minus. Otherwise, the problem's not as creative and exciting as I had hoped to be. All right, so the denominator is easy, right? These two things, we're not going to do all this FOIL and distribute. We're just going to take that, and we're going to multiply it by that. So don't distribute. Don't do any of that crazy stuff. Y minus 7. Sorry, brain's not thinking very good today. Minus the square root of 7. All right. Now, the numerator, I get the square root of y here. Square root of y times the square root of y is just y. This is minus the square root of 7y. This is plus the square root of 7y. Those just go away. And then the positive square root of 7 times negative square root of 7 is negative 7. And I'll put that in parentheses. Now, I'm hoping that as you look at that problem, you realize to yourself, hold on a second, there's a y minus 7 in the top, and there's a y minus 7 in the bottom, so those just cancel. Now, you can't just get rid of the whole numerator. Remember, if the whole numerator goes away, there's still a 1 there. And this is the square root of y minus the square root of 7. The reason there's a 1 there is because these actually divide to make 1. All right. Let me give you a weird definition. Just want you to get used to looking at some math stuff. Oh, God bless it. Jeez. Oh, sorry about that. If you have headphones on, I really apologize. You're probably pulling them off. Like, ooh, it'll wipe your ears off. Don't get too close to the screen. You might catch whatever the hell I have. So we've got a definition. This is going to look weird. If you had me last year, you saw this stuff. You probably just don't remember it. Just write that down. I'm going to tell you what it means in a second. So what this stands for is A, there should be quotation marks. A is in the set. That's what this means, by the way. This little E is in the set of all real numbers. This symbol right here, this little crazy R, that just stands for real numbers. Real numbers are rational. And irrational. And this one, I really am sorry about that. I'm not going to write this down. This just stands for N is in a set of all integers. This is integers. Actually, what it means is it's a positive integer, because you can't have a negative root, right? You can't have a negative root out here, right? There's no such thing as a negative cube root. That doesn't make any sense. Negative exponents just go in the denominator of a fraction. All right, so and if you have, and this is something you guys already know, a to the m over n, this is equal to the nth root of a to the m, right? You guys learned last year that this is the root and this is the exponent, or the power, whatever your teacher taught you. You guys learned that. So if I give you, let me go through another example. Look, if I give you something like this, now you got to be careful with these. 5b to the negative 2/3. And I said write that using radicals. Well, the first thing you're going to say is, okay, I have a negative exponent, so I'm going to deal with this negative exponent first. And if it's a negative exponent, that means it moves. So that's going to go down here. Now, you got to be careful, because the only thing being raised to that exponent is the b, not the 5. So I'm going to rewrite what this is equivalent to. This is 5 over b to the positive 2/3. And then I'm just going to rewrite it. 5 over, now remember, this is the root, so that goes here, b squared. Now, if I asked you to rationalize, you'd have to do different. But other than that, that's all you got to do. Oh, I'm so sorry. Let me get through this as quickly as possible. I only got a few more examples. So 7x to the 2/3. I hope I'm in school tomorrow. I hate being sick. I'm like the biggest baby when I'm sick. All right. So the 7 is not being raised to any exponent. The x is being raised to the 2/3, and the y is being raised to the 2/3. So notice both of these have cube roots, right? So this is really equal to 7, the cube root of x squared, the cube root of y. But since both of these are in cube roots, you can just put them together. This is 7 cube roots of x squared y. Another one. All right, so this one I want you to write. I'm going to give you it in radical form, and then I want you to write it using rational exponents. So the directions might say something like that. Write using rational exponents. In other words, get rid of the radicals. All right, so here's the example. 3, oh, go away. 3x cube roots of x to the 4th. All right, so we're going to rewrite this. 3x times x. Again, the root goes in the denominator, so that's 4 thirds. But you're not finished yet, right? When you have the bases the same, we add the exponents, right? So you will have a calculator. You could just do 1 plus 4 thirds. But those of you that actually have a brain, you kind of know this is 3 thirds, right? So 3 thirds times 4 thirds is 7 thirds. I don't care if you use the calculator or not. You can use a calculator. Mr. Hertwick's letting his kids, so I guess I got to let you guys. Oh, God, I hate those things. All right, I think we got 3 more examples, and then I'm out of here. I'm going to go lay down. This one's a little weird. We like to call this the Pursuti question. Really just a little weird. So we got the 4th root of... Hold on a second. Did I miss something? No, I didn't. Sorry, children. All right, almost done. All right, the 4th root of... the square root of x. What? Well, another way to write this would be the 4th root of x to the 1/2 power. Remember what we talked about, right? The exponent, or the base, is the root is the denominator of the fraction. So the square root of x is really x to the 1/2. This should be a 4, right? So then if I want to, I can rewrite this further. The inside is x to the 1/2. What does this root right here become? This is the 4th root. Well, the 4th root is 1/4 as an exponent. All right, so now we have an exponent raised to an exponent. What do we do with those? Multiply. So this is x to the 1/8. 5. 2 left. Get a little more complicated. To get a little bit crazier. 2, negative 2. X to the 3/2 times 4 x to the 2/3. And I want you to write this using radicals. Okay, fairly straightforward. Multiply the numbers together, we get negative 8 x. Now I'm going to add these. Yeah, if you want to, you can grab your calculator and do it, but it's kind of silly. Your common denominator is 6, right? So this would be 9 over 6. And this would be 4 over 6. And 9 over 6 and 4 over 6 is 13 over 6. So, if that's all I asked, that would be fine. What if I asked you to simplify it, right? Well, if I asked you to simplify it, couldn't I simplify this piece right here? Right? What's the root? The root is 6, right? So this is really negative 8 6th root of x to the 13th. Well, now, because we simplified a little bit earlier today, I'm looking for groups of 6. So wouldn't this be negative 8 6th root of x to the 12th times the 6th root of x? Notice how there are 13 x's here. Right? This one is a group of 6. How many groups of 6 is that? 2. So this answer becomes negative 8 x squared 6th root of x. I'm not sure I'd ask you that. I definitely would ask you to get to here. maybe not to get to there. All right, last problem. Promise. We're out of here. 6. I want you to write this using, I just want to simplify this, I guess. X to the negative 3, x to the 1/2, x to the 3/2, x to the negative 1. All right, you're going to have a quiz question similar to this. I don't want you freaking out about it. Let's not freak out about it. First of all, let's look at these. Can't we put these two together pretty simply, right? That's 3/2. If I bring this down here, right? If I bring this down, it becomes negative 1/2, right? So if I put those two together, 3/2 and negative 1/2 is just 1. So that just becomes x. And then don't these three go down, and this one goes up. So x all over x cubed. And now we're almost done. These x's cancel. And I'm left with 1 over x cubed. There's a couple. Let me show you one more way to do that problem, because I know I freaked a bunch of you out. Let me show you the crazy, easy way to do it. Hopefully I don't need to. Well, I'll show you another way to do it. This one is a no-brainer. That one required a little brain function. This one, I need Bolivar, probably can get this one right. Just kidding. No way you can. All right. This is what I would do. I mean, if you want, you're freaked out about it, grab your calculator and just add these two numbers up. Negative 3 plus 1/2. Now, don't tell me that's negative 2.5. That's just really silly, right? Actually, maybe I wouldn't even do that first. Maybe I'll just move the negatives, because the negatives cause all kinds of problems. So maybe we'll make this x to the 1 times x to the 1/2 all over x to the 3/2 times x to the 3. So I just move the negative exponents because I don't like them. Now I'm going to put these together. 1 plus 1/2. Remember, when the base is the same, we add the exponents. That's x to the 3/2 all over 3/2 plus 3. 3 isn't 3 just 6/2. So 3/2 plus 6/2 is 9/2. Now, you could just use your calculator, add that number and add that number, add that number and add that number, and get these. Now, when I take these, I subtract them. What is 3/2 minus 9/2? 3/2 minus 9/2 is negative 6/2, which is really just negative 3. Well, x to the negative 3 is 1 over x to the positive 3. There's a number of different ways you could have done that problem. All right, kids, I'm going to put the homework assignment in Google Classroom for you to work on. Hopefully I'm in school tomorrow. We can go over that. If not, there'll be a review assignment for like a review quiz. It's a really, really good review quiz that I'll provide the answer key to, not the work, but the answers. And then when I get back to school, hopefully Wednesday, if I'm not there tomorrow, we'll just go over the whole thing, and then you'll take your quiz. It's a fairly simple quiz, honestly. It's not that big of a deal. All right, later, bros.